Right now, I want to go over some patterns in your periodic table just to help you guys when you're doing problems. And this will be a way to check your work. And as you get very comfortable with these patterns, you may eventually be able to write your electron configurations without using the diagonal rule. So I've taken a copy of your periodic table and I've color coded it for what I call blocks. And what I want you to do is I want you to take your periodic table and label these different blocks in your periodic table, and then I'm going to show you how these work. So once you have these labeled, what I want you to notice is that groups 1 and 2, and also helium, we call those the S block. Now, the reason why I have N next to S is because the energy level that these configurations end in will be the same as the row number. So if we look at hydrogen, hydrogen's in the first group of the S block. It will end in 1s1. If we look at calcium, calcium's in the fourth period. It will end in 4s2 since it's in the second group of the S block. Cesium will end in 6s, and since it's in the first group, 6s1. If we go to the next area in the periodic table, groups 13 through 18, with the exception of helium, these are called the P block. What this and the N is beside this because, again, the row number or period number will be the same as the energy level of the P sublevel that it ends in. So if we look at carbon, carbon's in the second period. It will end in 2p, and since it's in the second group, 2p2. Indium will end in 5p1. Astatine will end in 6p5. Now, if we look at the D, the reason why there's N-1 is because the energy level of the sublevel that it ends in will be 1 less than the period number. So if we look at vanadium, vanadium will end in 3d3. We'd be careful of exceptions. Silver will end in 4d10 since it's an exception. The last block is the F block, and this is one where you have to be especially careful, and you also have to be careful with the D block when period 6 and 7. Now I want to show you this because what's happening here is if you look at your periodic table, what I want you to notice is that cesium is atomic number 55, barium is atomic number 56, lanthanum is atomic number 57. So actually, if you look at 57 and 89, these are both actually part of the F block. You look at your diagonal rule, right after 6s comes 4f and then 5d. So here we have lanthanum would actually end in 4f1, and then we'd have 4f2 all the way up to ytterbium, which is 4f14, and then lutetium would be 5d1 all the way up to 5d10, which would be mercury. Same thing here. We have 87, 88, 89. So actinium would actually be 5f1, 5f2, all the way up to 5f14, and then we would have 6d1, 6d2, all the way up to 6d10. So just be careful down here when you're writing your configurations for these elements in the D and the F block. But this hopefully will help you to be able to check your work for the most case.